Active band pass filter is same like this passive, just we are going to use active component together with the passive components. So band pass filter, why we are going to this active band pass filter? So bandwidth or frequency range of the filters can be very small or selective, or it can be very wide and non-selective. So depending upon the value of R and C. So that we had already seen, I mentioned here. So the bandwidth of the pass band can be narrow or very wide. So it's really depending upon the value of the resistors and capacitors. Okay, at this center frequency, that is the resonant frequency, the output signal is at its maximum value. That's correct. And the phase shift of the output signal is same as the input signal. So that also we had seen here in this frequency response. So at this center or the resonant frequency, the output value is the maximum. And also you can see here, the phase value is 0, that we know that. So the amplitude of the output signal from a band pass filter, the amplitude of the output signal from a band pass filter is always less than the input signal. Why? Because in the normal passive band pass filter, we are only using R and C. So whatever the input you are applying at the output, it's going to be less because there is always some voltage drop across the components. Remember, you are using a resistor in the passive band pass filter design. So this is the passive band pass filter, right? So whatever the voltage you are applying, for example, if you apply 10 volt, or the output, maybe you will get 8 volt or 9 volt. So output is always less than the input signal because you are using only passive components. Okay, so because a passive filter is also an attenuator and giving a voltage gain. Okay, so voltage gain here is always less than 1. That is why you are getting output is less than the input. So to provide an output signal with a voltage gain greater than unity, then we need some kind of amplification between the input and output. So when we use this kind of amplification device in the circuit, so it gives two benefits or two advantages. The first one is you can increase the input level at the output. If you send 10 volt, you will get maybe 15 volt or 20 volt. It's depending upon this gain of this component. The another advantage is you can also avoid the loading effect. So remember, I mentioned about the loading effect already when we talk about operational amplifier. So this operational amplifier can be used as a buffer or voltage follower that can isolate two different circuits. So it can take the input, it can take the output of one circuit and give us an input to the next circuit. Right? So now this is the output of this high pass filter. We are giving us an input to this operational amplifier. And the output of this operational amplifier is given as an input to this low pass filter section. So by this way, we are avoiding the loading effect. So we do not have any impedance mismatching problem between these two passive sections. And another advantage is we are also getting amplification. We get the amplified signal at the output. So these are two advantages of introducing this amplifier element into this band pass filter. So to achieve these two benefits, yes, we need to use an op amp as a buffer in between. This is called active band pass filter. So it's not must you have to use this operational amplifier. You know, what are the other amplification elements we have in, at least you have studied so far in your previous course. So operational amplifier is one of the amplifier, and another one is transistors. Transistors, we can also use transistors as an amplifier in between. The transistor can also isolate these two circuits and it will provide the amplification. Okay, so anyway, in this example, we will see only the operational amplifier as the buffer. When you use operational amplifier as a buffer, what is the, you remember what is the circuit configuration of the buffer? So the buffer is like this. We have the negative feedback, but we don't have any resistor here in the feedback. So it means there is no, you cannot really control the gain of this operational amplifier. So here, that's what I mentioned here. If we use op amp as a buffer, then the gain is unity, because there is no RF and R1 in the feedback loop. There are no resistors. So the gain is unity, because we know this is the non-inverting amplifier, right? Because the input is going to this plus terminal. So this is non-inverting operational amplifier configuration. So what is the formula? 1 plus RF divided by R1. This is the formula, the voltage gain of non-inverting amplifier. So if I do not use anything, RF and R1, then the gain is just a unity. So how this component is helping this circuit? This component is helping to just isolate these two sections, but there is no amplification. But if we want amplification, what we have to do? We just have to add this RF and R1 and control the value of this A. So we need to introduce RF and R1 to achieve higher and adjustable gain. That's all about this active band pass filter. The active band pass filter is just, we are introducing the operational amplifier. We can introduce either as a buffer or as a non-inverting amplifier.